So when you have to take a derivative like this, without knowing product rule, you would just multiply out the expression and take the derivative of each term. So we do that here, and we get x to the 8th minus 2x to the 7th minus 39x to the 6th plus 29x to the 5th minus x to the 4th plus 5x to the 3rd minus 4x squared plus x. And then you derive each of those terms, and you wind up with this 8x to the 7th minus 14x to the 6th minus 234x to the 5th plus 145x to the 4th minus 24x to the 3rd plus 15x squared minus 8x plus 1. Then once you learn product rule, this becomes a lot easier because you can say that any function that's the product of two different functions, so if f of x equals u times v, then f prime of x equals u v prime plus v u prime. So now we can go back to that same example using product rule, and we get that u equals x cubed plus 5x squared minus 4x plus 1, and we derive that to find that u prime is 3x squared plus 10x minus 4, and v, which is the second function, is x to the 5th minus 7x to the 4th plus x, and v prime is 5x to the 4th minus 28x cubed plus 1. And so then we plug these into product rule, and we get that x cubed plus 5x squared minus 4x plus 1 times 5x to the 4th minus 28x cubed plus 1 plus x to the 5th minus 7x to the 4th plus x times 3x squared plus 10x minus 4 is f prime of x. And if we were to simplify, we would get the same answer that we got before we knew product rule, but we don't have to, and we can just leave it as this. So now we can do a second example with product rule, where the function we're given is 9x squared plus 4x times x cubed minus 5x squared. And so we separate that into u and v, and we find that u equals 9x squared plus 4x, and u prime equals 18x plus 4, and then v equals x cubed minus 5x squared, while v prime equals 3x squared minus 10x. And so then we plug these four known functions into product rule and get that 9x squared plus 4x times 3x squared minus 10x plus x cubed minus 5x squared times 18x plus 4 equals f prime of x. And once again, we don't have to simplify this answer, we can just leave it as it is. So another useful rule to know when finding derivatives is quotient rule, and it's very similar to product rule, except that instead of multiplying two functions together, you're dividing one by the other. So quotient rule states that if f of x equals u over v, then f prime of x equals v times u prime minus u times v prime, all divided by v squared. And you can actually derive the quotient rule from the product rule if you say that f prime of x equals u times negative 1 over v squared times v prime plus u prime times 1 over v, because that all equals vu prime minus uv prime over v squared, which is what quotient rule is. But a numerical example of the quotient rule, or a real problem with a function, is that if f of x equals x to the 5th minus 3x to the 4th divided by x squared plus 7x, we can say that u is equal to x to the 5th minus 3x to the 4th, while u prime is equal to 5x to the 4th minus 12x to the 3rd, and v equals x squared plus 7x, and v prime equals 2x plus 7. And so then we plug this into vu prime minus uv prime over v squared, and we get that x squared plus 7x times 5x to the 4th minus 12x cubed minus x to the 5th minus 3x to the 4th times 2x plus 7, all divided by x squared plus 7x squared, then that is f prime of x in this scenario, and we don't have to simplify it, we can just leave this answer as it is. Alright, and here we have a second example of quotient rule that looks a lot more complicated but really isn't. And it's that f of x equals x to the negative third minus x to the negative eighth divided by x to the negative 2 plus x to the negative sixth. And so in this case we have that u equals x to the negative 3 minus x to the negative eighth, and u prime equals negative 3x to the negative 4 plus 8x to the negative ninth, while v equals x to the negative second plus x to the negative sixth, and v prime equals negative 2x to the negative third minus x to the negative seventh. And then we plug these into quotient rule, and our final answer is that f prime of x equals x to the negative 2 plus x to the negative sixth times negative 3x to the negative fourth plus 8x to the negative ninth minus x to the negative third minus x to the negative eighth times negative 2x to the negative third minus 6x to the negative seventh, all divided by x to the negative second plus x to the negative sixth squared.